All right, students. Today we are going to cover 1.2 properties of exponents and scientific notation. So if you look at the board, we have 2x to the fifth. 2 is the coefficient, x is the base, and the 5 is the exponent or the power. So we're going to go over some of the properties in math you need to know. So when you are multiplying like bases, you need to add the exponents. So for example, we have x to the fifth times x to the second. In this example, we are multiplying. The bases are both x, so we're going to add 5 and 2 and we get 7. That's an example of the product property. That's what we call it in math, the product property. All right. Dividing like bases. When we divide like bases, we need to subtract the exponents. So for example, if I have x to the fifth over x to the second, that gives me x to the third because 5 minus 2 is 3. We subtracted the exponents. That is what you call the quotient property in math. Third, we have the power property, which is whenever we multiply exponents. So the power properties, whenever we have a power raised to a power. So for example, if I have x to the third raised to the fourth, as you can see, I have two exponents. I have a 3 and a 4, so it's a power raised to a power. When this happens, you multiply, and 3 times 4 is 12, so you get x to the 12th here. Also, you want to simplify all numeric bases and coefficients. We're going to get into that more on the next slide. Also, in math, one of the big things is you cannot have a negative exponent. So no negative exponent. So what does this mean? This means if you have an exponent, let's say you have x to the negative 2. You cannot have a negative 2 exponent. So I always tell my students to rewrite this as x to the negative 2 over 1, because putting something over 1 is fine. You're not changing it. And then you take this and you just flip it. And you're going to get 1 over x squared. When you move the numerator from the top to the bottom, that exponent becomes a positive. So just remember that this negative 2 is an exponent. I did a poor job of writing it, but that's an exponent. It's small. When you flip it, it then becomes positive. And here is what you would like to have. All right. So second thing you also need, well, another thing is any base with an exponent of 0 equals 1. So for example, if you have 50 raised to the 0 power, that will equal 1. Any number, any base raised to a power of 0 will always equal 1. And if you don't believe me, we have a lovely Desmos calculator. So go to desmos.com, click Math Tools, and go ahead and click the scientific calculator. And if you don't believe me, 50 raised to the 0 power is 1. 14 raised to the 0 power is 1. 78 raised to the 0 power is 1. Anything raised to the 0 power is 1, period. All right. And now you can go to this lovely page, and we are going to, I'm just going to number them 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so if you look at numbers 1, 2, 3, 5, and 6, they all have numbers. There's no variables anywhere. That means for these 5 examples, we can take them and type them straight into our Desmos calculator. So for number 1, let's go ahead and type that in. Parentheses. I'm going to go ahead and just clear this calculator. All right, parentheses, negative 10 raised to the 5th power. And my answer is negative 100,000. That's number 1. Number 2, negative 18 squared is negative 324. And remember, we can do this because they're all numbers. Number 3, we have parentheses, negative 3 raised to the 4th power times parentheses, negative 3 raised to the 0 power, which gives me 81. So this is numbers 1, 2, and 3 on your notes. 1, 2, and 3. If you need to, pause this screen. All right, so for number 1, we had negative 100,000, negative 324, and we also had 81. And now I'm going to move on to numbers 5 here and 6. And once again, go straight to your calculator. You can do this because it is all numbers. Whoops. I'm sorry, guys. Let me do it this way so I can still have access to my tools. Sweet. All right. All right, so number 5, we have a fraction. 4 over 4 raised to the negative 2. And if you notice, your answer is 64. Number 6, we have 2 raised to the 4th times 2 raised to the negative 6. And I'm going to go ahead and just leave it as a fraction, so you should get 1/4. So that's for numbers 5 and 6. 5 and 6. 64. So we got 64 and 1/4. And now we're going to go ahead and do numbers 4, 7, 8, and 9. Number 4, we have x to the 5th times x to the negative 5th. When you are multiplying, you need to add exponents. So 5 plus negative 5 gives you 0. But remember, anything raised to the 0 power will always be 1. So your final answer for number 4 is 1. All right, number 7 is a little bit more interesting because it's a little bit more complex. So when you look at number 7, you're going to notice this big fraction is in parentheses and it's all being squared. So we have exponents here on the inside and we have exponents on the outside. So that means we're going to be using the power property, which states you multiply when you have a power raised to a power. So we need to take each individual term and raise it to the 2nd power. So remember, this is 3 times m squared times n to the negative 1. So what is 3 squared? So let's look here. 3 squared. What's 3 squared? 9. And let's take m to the 2nd, raise that to the 2nd, and you get m to the 4th. And then we can take n to the negative 1, raise that to the 2nd, and you get n to the negative 2. And remember, I'm getting these numbers by just multiplying. 2 times 2 gives you 4. Negative 1 times 2 gives you negative 2. All over n to the 2nd raised to the 2nd. 2 times 2 is 4. So you get n to the 4th. Now, this looks great and all, but you are not quite done because there's a big rule in math that states you cannot have a negative exponent. So in order to do this, we're going to move that numerator and we're going to flip it and then put it in the denominator. So my new expression is 9m to the 4th divided by n to the 4th times n to the 2nd. And remember, when that n to the negative 2 goes to the denominator, it becomes positive. And then last but not least, the denominator, you can add those exponents since you're multiplying. So you get 9m to the 4th over n to the 6th power. And that is your final answer. All right, and now let's move to number 8 right here. So same concept, a little bit less complex, but we need to take each individual thing and raise it to the outside power. So we may have power raised to a power. So what is negative 4 raised to the 3rd power? Type that in your calculator. You should get negative 64. Then we have a to the 1st. Raised to the 3rd power means we have a to the 3rd because 1 times 3 is 3. Then we have b to the negative 2 raised to the 3rd. Negative 2 times 3 is negative 6. And this is looking better and better. However, we cannot have a negative exponent, so we need to bring this to the top. When we do that, we get negative 64 a cubed b to the 6th. And yes, that is your final answer. Okay, and then lastly, number 9. Number 9. We have x to the 4th times x to the 6th divided by x to the negative 8. All right, so first things first, I can simplify the numerator because when you're multiplying things, you can add their exponents. So 4 plus 6 is 10. So I get x to the 10th divided by x to the negative 8. When you are dividing, you can subtract. So 10 minus negative 8 gives me x to the 18th. If you don't believe me, please type that in your calculator, 10 minus negative 8. And you should get x to the 18th. And moving on, we have 4 more examples of properties of exponents on this next slide we need to complete. And once again, the beauty of these videos, if I'm going too fast or something of the sort, please feel free to pause, rewind, fast forward, rewatch, whatever you need to do. All right, so we have z, so it just says simplify each expression completely. So our goal is just to simplify it. We have z to the negative 5th divided by z to the negative 12th. So we know whenever we're dividing, we can subtract the exponents. So we have z, negative 5 minus negative 12 gives me a positive 7. If you don't believe me, just type it in your calculator. And once again, when you are dividing, you subtract. So it's negative 5 minus negative 12. These two negatives become a positive. So negative 5 plus 12 is 7. So that's why you get z to the 7th. But once again, just use that calculator. Moving on, we have negative 7y to the negative 11. I need to simplify this. And the biggest issue, I see it's a single term, it's a monomial, can't really combine anything. I don't see any bases that are the same anywhere, but that negative exponent is illegal. So remember, here we have a monomial. You can write this over 1. I didn't change anything by writing it over 1. I'm going to take the term that has the negative exponent, which is y. Y is raised to the negative 11, not 7, not negative 7, but just y. So I'm going to bring this down, and I'm going to be left with negative 7 over y to the 11th. And that is your final answer. All right, and then next we have y to the negative 1 times x to the 5th over x to the negative 4th. I can multiply the numerator. When you multiply, you add. So we get x raised to the 4th because negative 1 plus 5 gives me 4 over x to the negative 4th. When you are dividing, you should subtract. So you have 4 minus negative 4, which gives you x to the 8th. And once again, if you don't believe me, just go to your calculator, type in negative 1 plus 5, and you should get 4. And then we had 4 minus negative 4, which gave us 8. All right, and then last but not least, this lovely problem. I just want you to realize that we do have monomials here. We have a monomial, which is y to the negative 7th, times the parentheses, which is another monomial. Then we have this monomial times x squared. If you look, the things in the parentheses have a power. So this parentheses is raised to the 4th power, and so is this one. So our first step is to get rid of parentheses. So I'm going to look at the numerator first. So I have y to the negative 7th. That's going to stay there. Times, remember, when you have a power raised to a power, that's the power property you need to multiply. So we're going to multiply negative 2 times 4, and we get y to the negative 8th. And then x squared raised to the 4th is x to the 8th. Divided by, we're going to take 3, raise it to the 4 power. So 3 raised to the 4th is 81. We have y raised to the negative 2, which is then raised to the 4th power to a power, which is negative 8. And then we get x squared at the end. All right, then our next step, so we're going to go ahead and just move it on over here. We're going to try to simplify this by combining like terms if possible in the numerator. So in the numerator, I can combine these two because when you're multiplying, you can add exponents and you get y to the negative 15th times x to the 8th over 81 y to the negative 8 x to the 2nd. All right, and I'm just going to keep simplifying because in math you are not allowed to have a negative exponent. So I'm going to take y to the negative 15th. I'm going to bring it down. I'm going to bring y to the negative 8th, and I'm going to bring it up. So in the numerator, I'm going to have x to the 8th times y to the 8th over 81 x squared y to the 15th. And all I did was just move the y negative 8 up, move y negative 15 down. All right, then you can still keep simplifying. We're almost there, not quite there though. So when you look at this, you should notice that these x's, here's the quotient property. When you are dividing, you can subtract. So 8 minus 2 is 6. So we're going to get x to the 6th in the numerator. In the denominator, we're going to have 81, and we're going to have y to the 7th. Because 8 minus 15 is negative 7, but we can't have a negative, so we keep it at the bottom. And another way of explaining this is for me to go kind of talk about this in more detail. So this is your final answer. I'm going to explain the y's in 1 second. So if you just look right here real quick, we have y to the 8th, which is really y times y. 8 times all over y to the 15th, which is all right. So when you have y to the 8th divided by y to the 15th, you could expand y to the 8th and get all this and y to the 15th, and then we're going to cancel what can cancel. So this one cancels with this one with this one. And if you look, what do we have left over is this, and how many? Well, let's see, 1, 2, 3, 4, 5, 6, 7. And where is that y located, top or bottom, numerator, denominator? And you're going to notice it's in the denominator, so it needs to stay in the denominator because you don't want a negative exponent. So that is your final answer. All right, and now we're going to move to the second part of this lesson, which is scientific notation. So scientific notation is another way to write large or very small numbers. Some scientists and mathematicians, for the matter of fact, are very lazy. Instead of writing a big number like millions and billions, they would just write in scientific notation to make it short and sweet. You need to know the scientific notation has a special format or special notation. It always looks like a times 10 to the nth. And please note that a must be between 1 and 10. And keep in mind that the n is the integer, and integers, the integer will be positive when it's a large number, and when it's a negative number, it will be a small number. So positive for large numbers, the exponent will be positive whenever it's a large number, and the exponent will be negative when it is a small number. So just keep that in mind as we work through these examples. All right, so moving on to this page, we have 73,200,000, and when you read the directions at the top of the page, it says convert the following numbers from standard notation to scientific. So standard to scientific. And remember, scientific is a times 10 raised to the nth power. So I want to write 73,200,000 into scientific notation. So if you look at this big number, there's no decimal, but there's a decimal understood to be at the very end. Our goal is to make that decimal move between a number in between 1 and 10. So I need to move it in between the first two non-zero numbers, which I need to move it all the way over here because 7 and 3, 7.3 is between 1 and 10. So I need to move it once, twice, 3 times, 4 times, 5, 6, 7 times. My exponent will stay positive because 73,200,000 is a large number. So I have 7.3 2 times 10 to the 7th. And that is your final answer. All right, this problem in the middle is 0.0000151. That is a small number, so I know by default my exponent will be negative because that's such a small number. I now want to take the decimal that we see here and move it between a number that's between 1 and 10. So I want to move it to the right between the first two non-zero numbers, which happen to be 1 and 5. Because 1.51 is in between 1 and 10. So 1.51 times 10 to the 1, 2, 3, 4, 5, 6. I moved my decimal 6 times. And it does have to be a negative because that number, once again, is small. And if you move to the right side, we have the negative 0.000385. So what I tell my students with this negative is just go ahead and bring it down right here to your answer because it's going to have to stay there. So now kind of ignore it, so to speak, and just focus on the decimal. I want to take this decimal and move it between a number between 1 and 10. So the first two non-zero numbers. So 1, 2, 3, 4. So it's negative 3.85 times 10 to the negative 4th. Remember, your exponent has to be negative because this is a small number. This was also a small number. So remember, your small numbers will have a negative exponent, while your large numbers will have a positive exponent. And now I want you to take time, pause right here, and work these next 3 examples. I will go ahead and just put the answers on the board. Pause it and give this a try by yourself. All right, and I did write the answers for the next 3 on the board. So like I said, please pause this, make sure you got them right. If you have any questions, feel free to email your teacher, rewatch this video, or go on to Hawks and look at the Learn section and the practice problems as well. All right, moving to the bottom of the page, this is the same thing but in reverse. So here we're going to convert it from scientific to standard notation. So we're just doing the opposite. So the first one, we have 2.92 times 10 to the 6th. As you can see, this is a positive number. A positive number means my number will be large. So I need to take this decimal, 2.92. I need to move my decimal to the right to make it large 6 times. 1, 2, 3, 4, 5, 6. Here's my new decimal, and in place of all these empty spots, you just put a 0. So to go from scientific notation to standard form, my number is 292,000. In other words, it is 2,920,000. All right. Go to the middle example, 7.84 times 10 to the 3rd. This is a positive exponent. My number will be big. Since my number will be big, I need to move my decimal to the right 3 times. So 1, 2. Oop, 1, 2, 3. Sorry, can't count. Oop, let me just redo that. My handwriting got a little messed up there. All right, so it's 3. It's positive. It's a big number. Go 3 times to the right. 1, 2, 3. And in place of this empty spot, put a 0. So you have 7,840. So 7,840. All right. And then move into this right side, negative 1.428 times 10 to the 8th. This is a positive number. You need to move the decimal right 8 times. So we have negative 1,428. Here it is. Move it 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Here's your new decimal. In place of all these empty spaces, put some zeros. So you should get this as your answer. And I will go ahead and do this bottom right one with you with a -5, because remember, when your exponent is negative, that means it's a small. So this is a negative, so it's a small number. So we need to move this decimal left 5 times. So it's going to go 1, 2, 3, 4, 5. So it's going to go 5 units left. So your answer is 0.00005544. And then the last two on this page, go ahead and pause this video and give yourself a chance to give it a try, and I will write the answers on the board. And then go ahead and make sure you have these accurate. And remember on Hawks to always practice before you certify. And on this last slide, we have 2 last examples. So let's go ahead. It says evaluate the following expression. Use the property of exponents. Write your answer in standard form. So we need to write our answer in standard form. So I'm going to do the top one for you. So if you look at this, we have 5.8 times 10 to the 17th times 3 times 10 to the -15th. So I'm going to do the top one with you. So when we type this into our calculator, we get 5.8 times 10 to the 17th, close parentheses. Then we have 3 times 10 raised to the -15th. And we get 1740. So 1740. And we would stop right here because this is in standard form. Because if you already forgot, standard form is this. This is standard form, because here we converted from standard form to scientific. So we don't want it in scientific notation, we want it in standard form. So that would be your answer, 1740. This would be standard notation. And then the next one, don't let it confuse you, don't let it trip you up. It just gives you 3 of them. It's no big deal. Type into your Desmos calculator and then write your answer in standard form. And that's it for this lesson. Thank you.